Today we are going to learn about different properties. We have a few definitions. Our first definition is a commutated properties. This means the order in which two numbers are added or multiplied. So if our expression follows the commutative rule for addition, that means that, for example, we have 7 plus 9 equals 9 plus 7. We change the order of the numbers. That means that A plus B is going to equal B plus A. So even though the numbers are changed, they're still going to be equal to each other. They're going to have the same number. So 7 plus 9 is 16, and 9 plus 7 is 16, therefore those are equal to each other. And we also have it for multiplication. 4 times 6 is 24, and that still means that 6 times 4 is 24. So the commutative properties is in order of two numbers where they are switched. That means A times B equals B times A. Then we have an associative property, which is the way in which three numbers are grouped when they are added or multiplied does not change their sum or product. So the associative property for addition is right here. We have 3 plus 9 plus 4 in parentheses equals in parentheses 3 plus 9 plus 4. So the sum of those would equal each other. So we would have A plus C in parentheses equals in parentheses A plus B plus C. So it's saying that no matter what numbers we have plugged in for A, B, and C, that when we group them both of these ways, we're still going to have the same sum. So if we did order of operations and 9 plus 4 equals 13, and 3 plus 13 equals 16, does that stay true for here? So 9 plus 3 equals 12, and then 12 plus 4 does equal 16, so 16 equals 16. And then associative property for multiplication. That means we have 8 times and then the parentheses 5 times 7 equals parentheses 8 times 5 times 7. So you see how they're grouped different. Here 5 and 7 are in parentheses, and in here 8 and 5 are in parentheses. So then we have our standard rule that A times in parentheses B times C will equal in parentheses A times B times C. And this would be our associative property for multiplication. Here we have an identity property. Identity property is the sum of an addend and 0 is the addend. So the value of the number would not change. And for the product of a factor and 1 is the factor. So for example, our addend is 13. If we do 13 plus 0, we will always get 13. So anything plus 0 is that number. So therefore, anything, meaning A using our variable, plus 0 is always going to equal A. That's for addition. Identity property for multiplication is stating that a product of a factor, which a factor is 7, times 1 is always going to be that factor. Therefore, our rule using a variable states that A, which represents the factor, times 1 is always going to equal the factor A. And our last rule is an inverse property. The sum of an addend and its additive inverse is 0. The product of a factor and its multiplicative inverse is 1. So, for addition, that means that the addend 6, if I add that to its additive inverse. So if it's a positive 6, the inverse of that is a negative 6. So 6 plus a negative 6, or 6 combined with a negative 6, will always equal 0. That's what that states. Therefore, to use a rule in our variable that a positive variable a combined with the negative variable a will always equal 0. Those are using the same numbers. It's positive and it's inverse. That's for addition. Inverse properties for multiplication. So we have a factor, which is 6, times its multiplicative inverse. Multiplicative inverse of 6. So if I have a factor of 6, its inverse is 6 in the denominator with 1 on top of it. So factor of 6 times the inverse is 1 over 6 will always equal 1. So any factor times its inverse, 1 over that number, equals 1. So if I have a 7 and I wanted to multiply it by its inverse, I would say 7 times 1 over the factor, 1 over a, which is 7. And that's always going to equal 1. And that's because if I put a 1 over here and I multiplied it straight across, I would get 7 times 1 is 7. 1 times 7 is 7, which we know 7 over 7 equals 1. So those are our 4 properties that we are going to be using for the next few weeks.